impulse, cut off the border, and then cut on the double lines right there and right there, and you end up with these 3 separate pieces of paper. Okay? Go ahead and set these to the side, and let's write some notes. All right, impulse. Let's start off with a definition of impulse. Impulse is a change in momentum. So first of all, let's talk about momentum. When we talked about momentum, okay, that's the mass times velocity. The key to this was remembering that we were talking about constant velocity. The object is moving with a constant velocity, and if it has mass, then we have impulse. Sorry, then we have momentum. Okay? If we want to change the momentum of an object, we're usually talking about change in the velocity. Talking about a change in the velocity. All right? An object rarely instantaneously has a change in mass. Its velocity will change, but the mass usually pretty much stays the same. So if a change in velocity, this means it's going to speed up or slow down. Okay? It's either speeding up or slowing down. The velocity is changing. Okay? So that's what impulse is. When we go from one momentum and it changes to have a new momentum. So a constant velocity, that velocity changes, then it has a new constant velocity. All right, before we glue this in, we're going to write on it. There are 2 formulas to solve for impulse. This is a little different than we've faced before. Most of our things, we have just one formula. This actually has 2 different formulas to solve for the concept, to solve for impulse. Okay? The first one and the second one. Uppercase J is the symbol for impulse. All right? So under impulse there, write an uppercase J. It's joules if we're talking about units of measure, but this is a variable. So the variable symbol is uppercase J. All right, so this is impulse. What does the F stand for? Force. And the delta T? Change in time. What are my units of measure for force? Newtons. What are my units of measure for time? Seconds. My units of measure for impulse. Newtons multiplied by seconds. N.S. We just say Newton seconds. Now, that's one formula. That's one way to solve for impulse. If you know the force, you know the time, force applied and the time for which it was applied, that will give you the impulse. Here's another formula. It gets you the same answer, but using different numbers, different variables. Okay? So, again, uppercase J, that's impulse. What does M stand for? Mass. Now, delta V. What's V stand for? Velocity. A delta V is change in velocity. Okay? That literally means, if you remember, go back to the formula for acceleration, the final velocity minus the initial velocity. Units of measure for mass. Kilograms. Units of measure for velocity. Meters per second. So our units of measure for impulse can also be kilogram times meter per second. Aha, exactly. You should look at that and go, wait a second, that looks familiar. Yes, it should be. It's the same as momentum. Now that should not be surprising if we go back to the definition of impulse. Impulse is a change in momentum. So how much the momentum change is still momentum. Okay? We just have a name for it, impulse. Now, you should probably be going like, whoa, wait a second. What's going on here? All right. Newton seconds and kilogram meters per second are actually the same thing. They don't look the same, but they are the same if you look at the algebra, which we'll do here in a moment. But before we do, if you have that written down, go ahead, let's glue it in right there. Okay, so glue down that paper. All right, what I'm going to show you guys is on the OOPS page. You do not have to do it, okay? I just want to show it to you so that you know how on earth it's possible that Newton seconds and kilogram meters per second are actually the same thing, okay? I'm doing this at the bottom of my OOPS page. Like I said, not required in your notes. All right, so impulse has the two formulas. One of them is the force multiplied by the time. And when we do that, our units are Newton seconds. Okay? Let's talk about force for a minute. What's the one formula I asked you to memorize in this class? Force equals mass times acceleration. Okay. My units for mass, kilograms. My units for acceleration, meters per second squared. My units for force, we always say, oh, newtons. Well, newtons are actually kilograms times meters per second squared, for the obvious reason right there. We're just so lazy that that's such a long pain in the butt thing to write, we just named it after Newton. Okay? To simplify the chaos of trying to understand what's going on there and having to write those long units, we just call it newtons. Okay? Now, algebraically, you can rewrite that, okay? Kilograms times, hello?
Can we talk to Sky?
Yes.
Bring your pen.
Okay? Newtons times kilogram meters over seconds squared. Now, we want to know how this is the same thing as kilograms times meters per second. Well, here it is. Seconds. If I multiply seconds over here, and I might multiply seconds over here, that cancels right there, and you end up with newtons times seconds is equal to kilogram meters per second. Okay? So algebraically, that's how those two things can actually be equal to each other. All right? Now, if that totally was like, what did you just, don't worry about it. Okay? Just information. You don't have to put your notes. Just kind of trying to clarify. I'll never test you on it. All right, now, so technically that's all you really have to know about impulse. However, I want you to actually understand it. So I've come up with this. Don't glue it in yet. Let's write on it first and then we'll glue it in. An example. Easiest way to understand this is through an example. So we have a 25 kilogram shopping cart moving with a constant velocity of 4 meters per second. A force of 10 newtons is applied for 5 seconds. The shopping cart now has a constant velocity of 6 meters per second. Okay? Great, wonderful. That's our scenario. Now we're going to break it down and analyze it. Let's look at the object before. What is the mass of the shopping cart before the force is applied? 25 kilograms. What is the velocity of the shopping cart before the force is applied? 4 meters per second. So, simple application of the formula. Momentum is mass times velocity. What is the initial momentum of the cart? 25 times 4? 100 kilogram meters per second. Okay, let's look at the force applied. So it's moving along, minding its own business, constant velocity, doing great. Extra force is applied to it, unbalanced force. How strong is that force? 10 newtons. For how much time was that extra force applied? For 5 seconds. So the arrow represents the force, 10 newtons. There's a little stopwatch here, 500 seconds. Okay? So we have a force applied for amount of time. Now, because of that force applied for 5 seconds, the object now has a new velocity. What is the final velocity of the shopping cart? Look at the example. What's the final velocity of the shopping cart? 6 meters per second. What is the final mass of the shopping cart? It's still 25. It doesn't change. What is the momentum of our shopping cart after the force is applied? 25 times 6, 150 kilogram meters per second. Okay, now, impulse, uppercase J, is equal to change in momentum delta P. There are 3 ways to calculate the impulse. Okay? So the first way, change in momentum. So that's the final momentum minus the initial momentum. What is the final momentum of the shopping cart? Final momentum, 150. What is the initial momentum of our shopping cart? 100. 150 minus 100 is 50 kilogram meters per second. All right, the next way to calculate the momentum, the impulse. The next way to calculate the impulse, mass times multiplied by change in time. The change in velocity, sorry. That's supposed to be a V. Typo. Mass times change in velocity, typo there, correct that, is equal to the mass multiplied by the final velocity minus initial velocity. So what is the mass of our shopping cart? 25. What is the final velocity of our shopping cart? Right here, 6 meters per second. What is the initial velocity of our shopping cart? 4 meters per second. All right, so let's do the algebra. What's 6 minus 4? 2. What's 2 times 25? 50. All right? And that was kilograms mass multiplied by velocity, kilograms meters per second. Now the next formula. Force multiplied by change in time. What was the force applied to the shopping cart? 10 newtons. For how much time was that force applied? 5 seconds. What's 10 times 5? 50. And that's newtons times seconds, Newton seconds. Now, we just did 3 different ways for calculating, and what was the result? 50, 50, 50. Doesn't matter how you look at it, we got the same number. So, impulse is change in momentum. The momentum changed by 50. The impulse is 50. Whether you calculate it using the force, or whether you calculate it using the momentum, the change in velocity, however you want to do it, you get the same numbers. So we have two different formulas that give us the same answer. Now, does the idea make sense? Kind of comes together, hopefully. All right. Take that paper, glue it in.
We cut it already.
Yes. That's on the regular page. Okay, so that's on page 37. Now we are going to take the remaining paper, and if you look at this carefully, let's analyze it for a moment. Okay? Take it and just look at that first column on this chart. That. 1 second. All right. So with this paper, let's just take a look at that first column. The very first box. Notice it's that formula right there. Okay? Below it, it's the same formula rearranged to solve for force. And below that, again, the same formula, but rearranged to solve for the time. Okay? Next column is the next formula. The next box down is the formula rearranged to solve for the mass, and then the formula rearranged to solve for the change in velocity. Okay? Now the third column, we take these two formulas, okay, and we set them equal to each other. Because they're both solved for impulse, we can take those and set them equal to each other. And that's what we have here. The first formula, if we want to solve for the mass, given the force, change in time, and change in velocity. Then we have solving for the force, if given the mass, the change in velocity, and the change in time. Then solving for the change in velocity, given the force, change in time, and mass. And then solving for the change in times, given the mass, change in velocity, and force. Okay? So, with this one concept of impulse, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 different formulas. Ah! Lots of algebra there, lots of triangles and rearranging, blah, blah, blah. This, you get to put in your journal and use it to do your worksheet, and you'll be given the same one on the quiz. Okay? So, over to the OOPS page. Glue it in so you can access it and use it frequently. So use this formula chart as needed to work through the practice questions on the worksheet. Like I said, you'll be given the exact same one to use on the quiz. That is impulse. Fairly easy.